In here we have a specific image, and this image shows some things that we need to fill out to develop a question. And this here tells us that this particular object, as you notice here, it is known to be called an irregularly shaped object, and this here doesn't have a specific shape, and we are going to be weighing this particular object, and the recording here it says in air to be around 157 grams. And on the other side here, when we place the same object in water, we have the mass to be now quite different, which is around 46 grams. And what happens now is that other information that is provided is this particular liquid here, which is water, where this irregularly shaped object is immersed in. It has a density of around 0.9982 grams per centimeter cube. And so the question here is this: what is the volume of this irregularly shaped object? And in order for we to accomplish this, here are a couple of key notes to keep in mind when it comes to making this relationship work here. The key note here is that this particular immersed object in this particular liquid water here, before this object was immersed in water, the water line was somewhere around here, which is quite lower than where it is currently at. And the reason for this is because when you place an irregularly shaped object or any object in water, there is buoyancy that is at play here, and this buoyancy causes the water to displace from its previous volume to a current volume. And what does this mean here? This means that the change in the mass of the recording is related to this, how much of this water is displaced right over here. And so what we have to do is this: we need to be able to find a difference in the mass here. And so in order for you to accomplish that, the mass that we need to find that is displaced is equal to the mass in air minus the mass of the object in water. And so what happens is that this here in air has a value to be 157 grams. This here is minus the water, the mass in water, to be around 46 grams. And this here, once you solve it, that should give you the value to be around 111 grams. Now this mass that is displaced here is going to help us to determine what the volume is, and this here needs to be done with respect to water's density. And so what that results in is that we know that the density here is equal to the mass of the displaced water divided by the volume. We know that to find the volume, we have to do what? Divide our mass displaced by the density. We know that the mass displaced is around 111 grams, and this here is divided by the density of water to be 0.9982 grams per centimeter cube. And so once we do the math by punching this into a calculator, we see that this particular value divided by this value right here for density of water is equal to what? In this case, we have the value to be pretty much close, because this value is almost equal to 1 in terms of rounding to the nearest whole number. And so this here is equal to 111.2 what? Centimeter cube. And so this here is the volume of this irregularly shaped object when it is what? Immersed in water, compared to when it is just weighed in air. So I hope you found this really informative in terms of being able to find volume of an irregularly shaped object when we are associating it with the object that it is immersed in this case water. And I hope to see you all on the next one. All the same, stay smart as always and keep on practicing.